Hello, and welcome to the Alphacam 2019 R1 What's New videos. In this short video, we're going to be covering the enhanced functionality to our main automation tool, the Automation Manager. We have received many requests from users all over the world telling us that they would like to simplify the process of populating data for the Automation Manager and for the creation of reports. This led us to the investigation that we probably needed to read as many properties as we possibly could from your solid files, from your surfaces, and from your 3D enabled DXF files and flat files. So the first thing we did is create a new function called read file information on import. When you do this, you'll be able to read all the information that is available to us inside of that CAD file, and we will be able to take that information and pass it along to your reports and your labels. Along the lines of reading the information inside of the CAD file, if the file contains this information, we will be able to display it for you. The clearest example of this information is the ability to read the thickness of a solid and then display that to the end user so that he or she can sort by thickness, remove materials by thickness, or even assign a material from the database based on that material property. And finally, for those people that are working with complex parametric assemblies, such as those that you will find on a window or a door, we have added the ability to specify the hardware, which we call fittings, directly inside of a CSV file or text document populating the job. This provides tremendous flexibility for a company needing to generate complex decisions when it comes to what hardware must be associated with a particular door. It also provides significant synergy when connecting this system to an order type entry system. So let's review the functionality. I'm inside of my Automation Manager Plus, and if I go to configuration, you can see that in my flat solids processing configuration settings, I have turned on the ability to read the file information when I import. This is what will allow me to read additional properties from the CAD file, such as thickness, which is a really important attribute that I want to be able to associate with the job. So let me go ahead and clear up these files right here. So what is the objective? This is the workflow that we had in mind. I have a number of SolidWorks files over here, but I really don't know which material is associated with which part. I want to be able to simply grab the entire set of files from the folder. I'm going to let Alphacam automatically investigate what are the properties of the part, query the part, and then display the parts to me. So for example, I may not be interested in processing anything except the parts that have an inch thickness. And I'm going to associate the melamine material with those parts. Now, once the parts have been imported and once the information has been read, I can then sort the parts by thickness and potentially remove from the job those parts and or additional supporting information that is not relevant to the job. So now that I have the parts that are exclusively 1 inch, I can then right click and process the rest of the job. As always, the Automation Manager will process all of the different files, and here we have an example of the files that we recently processed coming directly from the Automation Manager. Finally, the last bit of functionality that I want to highlight today is the ability to pass parametrics to a complex assembly, as well as fittings or hardware to the main component and or subcomponents of an assembly. What I'm going to do here is I'm going to read directly a CSV file that contains a list of all my assembly pieces, as well as subcomponents and any potential hardware that is associated with those subcomponents. I'm going to be reading this CSV file. What is happening right now is that Alphacam is opening up each one of the components inside of that line item, and it's extracting the parameters, fittings, hardware, and any other pertinent data that was put inside of that line item. As soon as we have the complete list, we'll be able to open it up and we will be able to scrutinize what the contents of the individual line item are. So now that we've finished populating the list, I can then go ahead and open it up to see what this particular assembly has inside of it. Well, you can see that it has one door, which has the following components: a bottom rail, a left stile, a right stile, a lock rail, etc. All of the components that you see here, as well as having fittings associated with the master assembly. Now remember, you can always right click and say show a preview, and you'll be able to see what specific hardware was associated with that particular assembly. In this case, given the parameters and given the choice of hardware, this is what the assembly would look like. Likewise, if the fittings are not supposed to go all the way to the top level assembly, we have the ability to associate the fitting with a child of that assembly. In this case, for example, this left stile is the one that's getting the hinge. As always, we can right click and preview, and we can see the individual component populated with the individual hardware. So here's the component with that choice of hardware that has been associated with the fitting datums right here. Finally, one of the things that I wanted to highlight today is the construction of the CSV or text file that permits us have this amazing level of depth of functionality. By taking a look at the file in Excel, it is significantly easier to disassemble the information that we have to supply to the system. Now, by no means you need to have a license of Microsoft Excel, but it does make it a lot easier to visualize what is it that we're passing along on the file. Some of these parameters are absolutely self-explanatory. We need to know the name of the master parametric file. We need to know if this is a sub-component or if it's a main component, the quantity. You can even pass information such as the customer name or an order identifier, things that you may want to use to control the sequence or to keep track of your orders and naming for these files. We can also pass, of course, materials, but here's a really interesting column. We're passing along a column which represents a string of parameters: parameter name, semicolon, parameter value, parameter name, semicolon, parameter value, so on and so forth. The number of parameters you can pass is unlimited. Likewise, look at how we have a column called fittings, which is allowing you to set the fitting name, semicolon, the fitting value, or the file, to be more precise, which is associated with that particular fitting. And finally, you can even pass a layer map. This is what would allow you to control even the machining treatment that you have for these items. So it is extremely powerful. Finally, look at the contrast between a parametric file that has no sub-assemblies and a main parametric file that does indeed have sub-assemblies. All we have to do is flag that particular sub-assembly with the is sub, and then the system will recognize it as such.